we introduce our work on rethinking sampling in 3D point cloud generative adversarial networks. In this work, we examine the long-neglected yet important effects of point sampling patterns in point cloud GANs. Through extensive experiments, we will show that the sampling sensitivity of a discriminator is closely related to the generation quality of its coupled generator. Existing works have developed a variety of generators, but they all use PointNet with max pooling as their discriminator. PointNet Max, as the most basic point cloud processing network, is very limited in capturing shape details for a successful GAN. However, we found that advanced networks, for example, PointNet++, DGCNN, KPConv, all fail to be functioning discriminators. Understanding their failure mechanism and improving discriminator design is therefore important and urgent. To design a better discriminator, we first need to answer the following question: what should the discriminator examine for improving the generation quality? Since a shape point cloud is the points sampled from an object's surface, its quality should be evaluated from two perspectives: the depicted surface geometry and the point sampling. Arguably, geometry plays a decisive role and should be the main focus of a discriminator. To evaluate how a discriminator balances geometry and sampling, we introduce the concept of sampling spectrum to depict the sampling sensitivity of discriminators. A sampling-insensitive discriminator, for example, PointNet Max, may ignore the point density variations as long as it perceives a good overall shape. Such a discriminator could identify big geometric flaws as shown in A, but turns a blind eye to highly non-uniform density distribution, for example, point clusters in B. On the other extreme, a sampling oversensitive discriminator, for example, PointNet++, DGCNN, KPConv, can even tell the subtle difference in sampling patterns, for example, between furthest point sampling in C and uniform sampling in D, and hence can be very narrow-minded about what a real point cloud should look like. To generate point clouds with uniform density, we need a sampling-aware discriminator, which lies in the middle of the spectrum. Sampling-aware discriminators should be able to identify density-related artifacts such as point clusters in B, while not being too sensitive to different sampling patterns, such as the differences between C and D. In this work, we find two sampling-aware discriminators. 1. PointNet Mix, which simply concatenates the max pooling feature and the average pooling feature of PointNet. 2. PointNet Attention, which replaces max pooling or average pooling by an attention layer. Our experiments on ShapeNet chairs show that using PointNet Mix as our discriminator can generate shape with more uniform point density while maintaining high shape quality. Here the color shows the local point density, where yellow represents high density and green represents low density. We coupled PointNet Mix discriminator with different generators and found it can always generate uniformly distributed points, whereas PointNet Max discriminators usually yield clustering artifacts. Our experiments further reveal that the failure mechanism of PointNet++, DGCNN, KPConv, PointConv as functioning discriminators is closely related to their sampling oversensitiveness. Note that all of them leverage relative point positions or edge information during their feature extraction, which leads to a huge amount of gradients flowing along the surface direction, focusing on changing sampling patterns instead of supervising shape geometry. We design a diagnostic no-generator experiment to factor out the impact from generators and reveal that the gradients of sampling oversensitive discriminators prioritize adjusting sampling patterns over producing better shape geometry. Here we can see gradients from PointNet++ and DGCNN cannot update the shape in a correct way, whereas PointNet Max and PointNet Mix are capable of moving the points into good shapes. As conclusions, we studied the importance of sampling for 3D point cloud GAN design. We proposed a sampling-aware discriminator, PointNet Mix, and we found the failure mechanism of PointNet++ and DGCNN as functioning discriminators. For future discriminators, we suggest they should be more discriminative in shape and aware, but not oversensitive to sampling patterns. For the sanity check of any novel discriminators, one can leverage our proposed no-generator experiment. For more details, please take a look at our archive paper and come to our poster.